Hi, everybody. We're going to do a review of the first topics that are important in digital logic. So I'm going to do some kind of difficult problems, which would serve as a very nice review of this topic should you be taking a test. So let's go to an important topic first, and that's Boolean theorems. And I'm going to write a question that says, choose the expression that demonstrates a theorem that you know. So a theorem that you know is this one. X or XY is simply the same as just X. And I'm going to give you some choices there. And the question would have the choice. Let's see. It will have the choice. B prime plus B prime D plus C prime A. It'll have the choice BC plus BD prime plus BC plus BD prime E. And it'll have, let's say, the choice B or D, B prime plus C prime. Oops, sorry. B plus D times B prime plus B prime plus D prime, C prime plus C prime plus A prime. Okay, so that's the question. Choose the expression that demonstrates this. And you see initially that I don't have any X's or Y's, but this is just one of your theorems. So you could express that in terms of B's and D's and A's as well. But what it's saying is when one input is ORed with an AND of that same input with a different input, it's the same as just that same input. So what you have to do is look for a pattern here, look for the X plus XY pattern, and you might not initially have it. I have an X plus XY pattern here. I have X plus XY pattern there. And let's see here. I'm going to give you, in the question, I'm going to have the next line being solved. And you're going to have to tell me if it is using this algorithm or not. So the next line, I'm going to go B prime plus B prime D plus C prime A again. So it's not using that algorithm. So that one's pretty obvious. I didn't use the algorithm. The next one, I'm going to go B prime plus D prime, B prime plus C prime plus A prime. And then the next one, I'm going to go B prime plus D, B prime plus C prime plus A prime. And what I need you to be able to notice in a question like this is I'm going to look for the X plus XY. And here I'm seeing C prime is an X, and here's the X, and then this is a y. So if this was turned into x, which is c prime, then that would be our answer. So here we go. This question remains the same here. This remains the same here. And this got turned into a c prime by using that expression. So the correct answer here is C. Now let's do a De Morgan's theorem question. A De Morgan's theorem question. Let's do, here's a De Morgan's theorem example. I would have A, B plus C prime, D. And what I would have to do here is I would apply De Morgan's to this, and I would have A, and I would change the sign, B plus C bar, because De Morgan says that I can break up that bar if I change the sign. And then I would have another bar over here. Since those bars are the same length, that's the same as A or B or C prime plus D. And I can't go any, oops, D prime. I can't go any further than that, and that would be the answer to a De Morgan's question. Let's see, what else do we have? Let me give you a question where you're going to simplify an expression using the theorems. Here we go. Let's simplify an expression using the theorems. Let's say D equals A, B, A prime B, or C, ANDed with A or C. Then, oh, and all inverted here. Then that's the same as A prime B times, or ANDed with C, broke up that inversion. And A plus C goes along for the ride. I'm going to break that up again by changing the sign. And I have to be careful of the brackets in this question, because in this question, if you forgot the brackets here, then you're going to have a completely different answer. And when you have a completely different answer, you will find that answer. You could find that answer in a test. These are both the same length here, so it's just A plus B prime. Again, the brackets ANDed with C. Oh, that's a C double prime, sorry. So that's going to go away. That's going to go away. Let's see. And that's all with A or C. And that becomes AC plus B prime C. Again, brackets are important. And then we can expand this. And wherever we have two A's going through an AND gate, it's the same as just A. And two C's would be the same as just C. So I end up with a AC plus another AC from over here, right? AC plus another AC. Plus the A, B prime C plus B prime C. And then that'll equal AC plus, and now I see B prime C here twice. So I can factor out B prime C and get A plus 1. And A or 1 is definitely just going to be 1. So AC is ORed with a B prime C and 1, which would be the same as B prime C. And then if you want, you can factor out the C. So your answer is either this one or this one. So that uses some theorems to simplify. And let's say one of the questions is you have to draw that circuit. That's a nice one to draw, or maybe we'll do a different one. We'll come up with an expression from a circuit. Here's a circuit. Here's an example of come up with an expression from a circuit from a midterm level type of question. That's an AND gate in there. Drew kind of small there, and there's an inverter before that. So if we were to come up with this expression, the expression, I would say, well, X is at the end of this expression, and X is coming from this OR gate. OR gates look like this with a plus in them, and one side of that OR gate has an A, and the other side of that OR gate has an AND. And something's going in that AND, it's a B, and then something else is going in the AND, and it's inverted, and it's an A. So I would say that the overall expression is A plus oops, I'm trying to shortcut here, plus A inverted B. And that's definitely a final, the A expression, but now at this point, make sure that you realize that this is not simplified. This is not a simplified expression. We see that this is theorem 15A, where x plus x inverted y is equal to x plus y. Therefore, we can simplify this further and say that this equals A or B. And that's the final answer on this one. All right. Let's do an analysis by substitution, which means we sub ones and zeros into an expression. Analysis by substitution. The question says, let A equal 0, B equal 1, C equal 1, D equal 1 in X equals A prime B C, A prime plus D, A prime plus D, like that. So then what you do is you literally let it equal all of its values and show all of your work. Zero or 1 would be 1 inverted. 1 and 1 and 1 and 0, which would be a 0. And that's how you solve that kind of problem. Back up to the top. Draw the circuits. All right, so I'm going to give you a circuit to draw. And I'm going to say that draw the circuit for this. X equals A and B. And B prime, or yeah, and sorry, X equals A or B, and B prime, B inverted, or C. So I'm going to draw this, and I know, so I see that X is coming from an AND gate. Into that AND gate, I have this side and this side. This side is an OR with A going in, B going in, and the other side is also an OR. I know that because there's a plus, and B inverted is going to go in, and C is going to go in. So that's going to be my circuit. Let's see. An exclusive OR, a unique exclusive OR type of question that's going to be helpful to you goes like this. Simplify. Simplify an expression with exclusive OR in it. So if I were to simplify that, I could use a De Morgan's theorem. And that breaks these up. And then that's x inverted plus, oops, wrote down the question wrong. Should be a y. Plus y exclusive OR z is a thing. And then you have to remember your pattern of what exclusive OR is. It means yz with OR in between and inverted here and inverted here. So this would be our, if that's available as a final answer, that would be your final answer. Truth tables. Let's say truth tables. I could ask a question. How many lines? And the expression is x equals a, b, or c. And you would say that n equals 3, therefore 2 to the n equals 2 to the 3 equals 2 times 2 times 2 times 2 is 4 times 2, 8 lines. And then I could ask you to make that truth table. And you would have to know that there are 4 zeros and 4 ones in that truth table, and then there are 2 zeros and 2 ones. And then there are 1 0 and 1 1 in this truth table. And then X would be the answer here. And then what you'll be doing is analysis by truth table, which I have down here somewhere. Analysis using truth table. So in order to solve this, you would be plugging in each value of the truth table. So let's look at the truth table section for this question. So let's do the analysis using truth table over here. So I would go A and B is 0, or C is a 0. A and B is a 0 or C is a 1. A and B is a 0 or C is a 0. A and B is a 0, or 1 is a 1. A 1 and 0 is a 0, or 0 is 0. 1 and 0 is 0, or 1 is 1. 1 and 1 is 1, or 0 is 1. 1 and 1 is 1, or 1 is 1. And that's analysis using truth table. And how did I know that? Because of the truth table of and the truth table of or. Truth table of and says 0, 0, 0, 1. Truth table of or says 0, 1, 1, 1. And that's how I figured that out. Boolean algebra just is to know our expressions, that this means or, and a dot means and a line means inverted, and we can write expressions like that. You have to know how to write those expressions and what those mean. Basic gates, you'll have to know the truth tables for the basic gates and symbols. So an example of a basic gate problem is represent NAND in two basic gates. So NAND looks like this. And the solution would be this. It would be an and an inverter. And that's how you would represent an and with just basic gates. Let's see what we're missing here. So converting number systems of binary to and from decimal, and also showing your work. So with a binary number, let's say this is our binary number 10110, then we have to say that this is 2 to the exponent 0, 2 to the 1, 2 squared, let's just not do this many, because on your exam I would not do this many, 2 cubed. So 2 to the 0 is 1. 2 to the power of 1 is 2. 2 times 2 is 4. And 2 times 2 is 4 times 2 is 8. So I have no 8s because there's a 0 up here. I have yes a 4, I have yes a 2, and I have no 1s. So I would say that 0, 1, 1, 0 base 2 is equal to 4 plus 2, which is equal to 6 base 10, is how I would show my work from for binary to decimal. And that's all of my examples. So thank you for joining me. Those are all of the basics of digital logic, the first types of topics you get into in digital logic. And I hope that was helpful for everybody. And if you have any questions, by all means, send me the questions as we're going and afterwards as well. Thank you so much.